And basically, a hacker, hardware hacker, who has remade the Commodore 64 for the new millennium. And I'm actually looking forward to hearing this talk myself. So here's Jeri Ellsworth.
So can anyone hear me with this on? Is it working all right? No? Yeah, okay. All right, I don't know exactly what I'm going to talk about today. It's going to be kind of rambling and free form and stuff. But maybe I'll just start with explaining who I am and what I'm about, kind of. Give you the basics on that. As you said earlier, my name is Jeri Ellsworth. I started in computers pretty early. My dad bought me a Commodore 64 in like 82 or 83. They were pretty new, and I was just totally fascinated with it. And I would sit in front of this thing. It was sort of a black and white TV, and just stare into the thing until my eyes just glazed over. And like 6 hours after school every single night. And then summertime was great because I could just like wake up, noon or something, and then work until the middle of the morning. And just doing that. It's a very exciting time for me. Didn't know anything about computers back then. I was typing things on the draw house. And I would say syntax error. Paint house, syntax error. I just kept plugging along and learning more and reading magazines, lots of magazines, anything I get my hands on, and going to the library and reading out-of-date books, things from the early 70s or 60s, talking about core memory, and I had no clue whether it's core memory in this Commodore 64 or not, but it's fascinating. Trying to convert all kinds of programs from other computers, TIs, and work on this basic. Never worked. I was really fascinated with how the insides of the computer worked. And, I remember that my father bought me a video game cartridge. And I just looked at this cartridge and I figured there was just connections inside, like wires connecting to other pins. And if I could do something like that, I could make my own video games. So I started jamming pieces of metal and smooth forks and nails into the back cartridge slot of my Commodore 64 and burning the thing out. I must have burned out 2 or 3 of the things that my dad had taken back and under warranty. I think I bankrupted Commodore. So I burned out a couple Commodore 64s, and the thing ended up being out of warranty at one point. And I don't know, I was just stupid. I just kept trying to do this thing too, because it made funny colors on the screen. I was close. Do something. And so I burned the thing out. My dad's like, "Well, I'm sorry. We don't have any money to get it fixed, and it's out of warranty. You're just out of luck." So it sat there, and I was really depressed and sad for a while. So I said, "Well, I'm going to open the thing up and see if I can fix it myself." And open it up, and there was a fuse that I'd blown inside. So I got some tin foil. Recommended procedure. So wrapped some tin foil around it, stuck it back in there, and got it working. I said, "Wow, I'm really good at electronics." So I don't know, it's kind of a start for me. It's like, wow, I can really do this. So I started learning about digital electronics, built some little mini projects. I guess in junior high or sometime I made this audio digitizer out of discrete logic. It was probably my biggest achievement. It was huge, and for you that know the Commodore 64, you remember that they don't have very good power supplies. I couldn't figure out why I kept going through power supplies on this thing. I was going to plug my digitizer in. The thing had so many chips on it, it was probably drawing 1 amp by itself. It would just overheat the power supply, burn it out. I would chisel through the epoxy on the inside of the power supply to get to the regulator, fix that, burn it out over and over again. So I got a little bit older. People started taking sympathy on me and giving me old test equipment, old scopes and stuff, like 2 megahertz scopes and stuff. Read more, just got really fanatical about it. Did a little bit of programming. And probably when I was 17 or 18, I had a dream of making this enhancement with C64. The Amigas had come out, and there were other 8-bit computers that had better graphics. And I was like, wow, I just have more colors on the C64. I want to make this video card expansion. I blocked it all out, and I was like, oh, if I could just do this or that, I can make it work, but it was just way above me at the time. And after I got out of school, I played around doing some race car stuff for a while, and got kind of away from the electronics. Did that for a while until I got tired of getting cut and burnt and stuff welding on cars. So I decided, well, what can I do? And I said, well, I'm pretty good at computers, so I opened a PC computer store. I can do this. I never owned a PC, but jumped right in, and with a partner, we opened a computer store and started building PCs and selling those, and got a little bit of money, and then I got back into electronics again. It was probably like 21 or so. So started playing around with pals and stuff like that. Simple programmable logic. Still wasn't enough to do what I wanted to do, but just learned more and more, and then eventually these FPGAs came out, these programmable chips, these big ones that could do a lot of stuff with it. So, okay, it's time. I'm going to make my Super Commodore upgrade. So originally what I had planned to do was make a Palmtop C64 for myself. So just out of the blue, I started making this video controller. Well, I need to get the video going, so I could do this. So I started working on this really simple video controller, and 2 years ago I went to a computer show, and I brought this very primitive video controller that I built. And it's like, oh, if anyone's interested, I built this video controller. I can do 4,096 colors. To a Commodore, and people just flipped out. Oh, you got to build that into a product. Well, I was planning on making this little Palmtop thing, this FPGA thing, and thinking anyone would be interested. And pretty soon all the emails started rolling in. I said, wow, this is incredible, you got to do it. Add this feature, add that feature, and so now I ended up with this board with all these features I never intended to have. It sounded interesting. Maybe I should talk about how I went about the reverse engineering of some of this stuff. It's actually, the Commodore 64 is a great platform because it's really well known. A lot of emulators have been made for it. They did a lot of tests with oscilloscopes and logic analyzers to make sure that they knew all the exact timing on, so they could do software emulators. So I've used a lot of the software emulator documentation to know what to do in that, to reproduce the hardware. And some of it's correct and some of it's wrong, but it works anyway. As far as the emulator documentation is what I mean, I guess. It works for software, but it's not really what's happening in the hardware. So the trickiest part of the C64 is the video chip, because everything is synchronous to it. The CPU is locked to its frequency. It generates all these different things. Like the video chip, if it needs more information, it'll halt the process, which is arbitrarily halted, and then programs, a lot of programs to advantage these different situations that happen with the halted processor and do things. It's been kind of difficult to try to emulate that stuff. Yeah.
So this is really neat. Why is this? Maybe you can talk a bit about why this is more fun than just running an emulator on a pocket PC. I know to me it kind of relates to the last museum issue of why not just keep emulators for all these machines rather than keeping the hardware. So I mean, it sounds like more fun to me, but I can't really describe why.
Well, for me, I'm into hardware, so I think software is cheating. So I do most of the time. I just a lot of times I do hardware where software probably would have been better. But for me, I just never really liked the emulators. So I like the real hardware. I like something I can jam a screw into it and short it out and have smoke come out. And burn it out. There's same feel I did personally, I know, out of that. So it was very exciting that, you know, I could make some real hardware and make some enhancements to it. That was fun too. At first I just wanted to have a C64, but then it's like, well, I'm going to add this and I'm going to add that, and then it's just like.
So what's your goal with your Commodore One?
My goals with the Commodore One?
What's it supposed to do?
Okay, my goals on the Commodore One are, it's changing. It's constantly changing. Originally, it was to be just a Palmtop, and then as kind of evolved, as people wrote me and said, "Well, do you think you could add this? This would be really useful. You know, I think I could use the C64 in a kiosk. If you just added this feature to it, where this piece of equipment is no longer available. So can you add some USB keyboards?" So it's constantly evolving. I think it's pretty much firmed up to what it's going to be, and what it's going to be is just basically a reconfigurable computer that's not necessarily a Commodore. It's going to have a mode that works like a Commodore, and it's going to have other enhancements where, like better video modes, we do up to 1280 by 1024 resolution, and 16-bit color depth. That's 65,535 colors or something like that. So went along, I added things like poppers and glitter to it, like the Amiga has.
Yeah, another question. Then it seems like part of the problem is that Commodore 64 software is generally written assuming the speed. So generally, you can make it faster, and in some cases, it might be useful to run the software faster, but for other things, you have to run it back to the original clock speed.
That's a good point. So what he's saying is, the old software was very time critical. It had software loops in it, and the Commodore One will break a lot of that stuff, and especially if you run it full blast at 20 megahertz. You know, hardly any of the stuff that uses these software loops is not going to run right. Your game, Pac-Man's going to go lightning fast. You're not going to be able to control it. So I'm trying to work in there at least a mode that's somewhat close to the original C64 timing, so that most of the software will work. With my old prototype, I was able to make quite a bit of the stuff work on it. And it's just like these European demos and stuff where they squeezed every ounce out of the CPU on the original C64. Now those have all kinds of problems. Which, since it's reconfigurable, that's something I can keep working on, and someone else might even be able to work on. To back up here a little bit at how the Commodore One works when you first power it up, there's the compact flash part. So it starts up and it looks and sees if you have a compact flash. If you have a compact flash that goes ahead and goes to a boot sector area on the compact flash, starts up, and then it takes the configuration data to configure these two programmable chips right at startup. So at startup, that's when it's told that it's a Commodore 64 or a TI-99 or whatever is written to fit into these FPGAs. So you can put an entire C64 on here that's exactly cycle accurate if you wanted to. That's not exactly my goal. I'm going to kind of work towards that. But, so, yes.
What did you do about the sound chip, the SID? That was mostly analog.
Yeah, the SID's still up in the air a little bit. Yes, the SID that I came up with, as far as I can tell, it's exactly the same as the original SID as far as the waveforms are generated. That's pretty well known, and actually, I believe his name is Guiness, something like that, that actually gave a speech and talked about how he built the original SID. So I just reproduced that exactly, the same accumulators and the same waveform generators. Now the part that's tricky on the SID is the filters. They have these analog filters that are different from one SID to another. I mean, off the same wafer, when they dice them up, I understand that even two chips that came off the same wafer are different sounding. And some people take advantage of that. And the music sounds really good on one SID and doesn't on the other. So what I did is I worked on a fifth order FIR filter, which is a digital filter, fully digital. And it has these constants that you can program. There's 5 of them. And you can play with these constants and you can change the different response times with the filter. And I open those up. There's registers you can write to. The user can write to those. So what I put in there for a default you don't think sounds like your original SID that you like so much, you can play with those and maybe you can get them closer to what the original is. There were some other cool things about the SID. There was some feedback that happened where they actually took part of the output, fed back into it to make these different modulation type effects. That was kind of tricky. I don't know if I've got it. I'm not very good at distinguishing all the differences between each different SID. But, I have some amount of feedback that you can play with in there. That might be the most difficult thing to get correct. The SID. I added more channels to it. There's 16 channels now. Just had enough bandwidth to go ahead and do that. So the original 3 are banked into normal location. And then you have the second SID location where the rest of them reside. And I put DMA controller in there so that you can play back samples.
There's a company that makes a musical instrument around the SID.
What was that?
There's a company that makes a musical instrument around the SID chip.
I think there's a couple actually. So MIDI device and there's one that's a keyboard. And some people have approached me. I don't remember exactly who it was approached me, but there's people interested in taking these things and maybe getting rid of some of the other features and just sticking a lot of SIDs into these programmable chips. You can do that. You can say, I don't want the fancy video. Let's just put 50 SID channels in. So that might happen. Yeah, these DMA controllers, you do modern wavetable kind of effects. Play 16-bit digital samples, which will be fun. And you think C64 hasn't done before.
What tools do you use to program the FPGA?
Well, I started out using just the free software from Altera, and then later on used a little bit better tools to simplify. Is actually the tool I like to use the most. I can get a little bit better results and pack more into the chips. Oh, the language I use is VHDL. The top level is schematic. So on the top level, I just have all these sub-blocks and then wires and everything on the top, so I can put 4 SIDs in if I want or whatever. So it's a little more modular that way, or 2 video controllers, and then compile it.
And with the 6502, did you write that?
I've written a 65024 core that doesn't work, and there's something glitchy in it. But it's not a high priority, so eventually I'll fix that. There's a lot of people out there that have free 65024s and various boards out there. I actually, on this board, I used Western Design Center 65816 processor, which is faster than probably what I can make in this speed grade FPGA anyway. So it's just easier to buy a $5 part than burn up all the space inside this. On the new revision, which should be ready in December, I took out the CPU that's soldered right to the board and put a slot here so that you can plug in 6809s or real 6502s if you want to have that exact emulation going, or Z80s or multiple products, or multiple CPU products. So that should be fun.
CPU right now is not in yet.
It could be. Put it in. That's not a big issue. It's just going to take space, and I'm using 100,000 gig parts. This one has 2 parts in it. The new design, I've reduced it down to 1 part. When I made this prototype, I needed I/O pins for PCI and all this other stuff, and I didn't want to worry about multiplexing and all this stuff. So I slapped 2 parts down. But, now we're going to produce these things. I have to cost reduce it, make it so it'll hit the $200 price range. Talking about, maybe I should cover that, is who's going to make this. Come to an agreement with a company in Germany who's going to manufacture it for me. They make a lot of Amiga peripherals called individual computers. So they have a lot of experience with assembly, so that's pretty exciting. So there's been working closely with Jens Schoenfeld. He's been helping me make sure that it's mass producible at the right cost. And he already has the distribution network set up. So over in Europe, at least, there's going to be pretty good access to them. Here, it's probably just going to be me selling them, and a few people are interested in bundling together some systems and putting hard drives and software and stuff. Maybe I should back up and just talk about the features that are on this real quick. I'm bouncing all over here. What it has is PCI slot, compact flash, one IDE channel, 1.44 floppy, uses SD-RAM, and access up to a gig of SD-RAM, PS2 keyboard and mouse port, VGA out, and it has the two Atari, Commodore, Sega type joystick ports, which I've remapped the D-Day, the paddle buttons and stuff, so it's more the Sega type of controllers. You use the extra buttons, which is good. It's kind of irritating making games and stuff. We only have one button on the joystick. It has stereo out. It's a 16-bit DAC for the SID and whatever sound generation you want to do. And it has some ports at the bottom that part of them are first section of it is Commodore compatible pinouts, and the rest are just extra signals that come down that are can be programmed to do other stuff. And, a parallel port. And originally I was going to have, I think this still says it was going to have RS-232, but that's probably going to be a separate add-on since it was burning up too much space in my chip. So I've added Amiga clock ports on it, the Amiga 1200 clock ports, which is a lot of peripherals that you can plug onto these clock ports. So I added 2 of those to it for the new revision. So that's kind of exciting because they have USB controllers and all kinds of stuff added to the clock ports.
What chips are on there besides the FPGA?
Well, there's some support chips here for this little guy down in the corner. Does the startup sequence. When you first power it up, it looks at the compact flash and IDE and configures these to get so these guys aren't brain dead anymore. Starts them up, and then once these guys start, then you have state machines and stuff in there that take the contents out of your compact flash and put it into the main system memory, copy your ROMs.
So this is really
What was that?
That is really proper.
This one here? No, this is the PLD, just a cpld. So it just has a simple state machine in there. It knows just enough to talk to the IDE channel, and that's about it. And then serialize the data. There's RealTime Clock, a little Dallas semiconductor real-time clock that's not stuffed on this board. And that's about it. There's not a whole lot. It's all these FPGAs gobbled up all the chips that are normally inside the regular computers. So you can mimic that kind of hardware right in there. And it's really fast. I mean, the clock rates you can get inside the chip to do things extraordinary, in the hundreds of megahertz sometimes to design right.
So the clock is controlled in the
Yeah, I made an NFM decoder and encoder.
you design that.
Yeah, I did. Yeah, digital phase lock loop. That was a tough one. That was actually, I'm pretty proud that I got that to work. The discs are very hard to read because you're constantly slipping and sticking as they spin. So you look at your signals that are coming in. You know, one time you look at it, your pulses might be nicely spread apart, a couple microseconds apart. The next time it spins, it might stick a little bit. They might be 20 microseconds apart. So you have to try to adjust for that in real time to catch it. And it does pretty good. It does all the CRC checking stuff. And you can rip and write raw MFM straight off of it. So that's, you can read almost any kind of disk with this controller. And imagine if you could get the RPM right to read GCR off of it too. My new design that I'm working on for December, I spent a lot of time. The memory seems to be limited to about 50 megahertz on this particular board, so I hunkered down the new specification for the SD-RAM, or I mean the specification for SD-RAM to make sure that I got all the source termination right, equal length traces, like right to clock drivers and stuff on it. So I can get more bandwidth out of the SD RAM. The new board's also going to have a little bit of RAM on board for video generation. This particular board, I'm fetching all the data out of the SD RAM and then generating the video, and it's starving other components like the glitter and the copper and stuff don't always get consistent access to it. So as far as a programmer that likes to program things per cycle, it's going to be very difficult. I don't have video RAM on board, so I'm doing that on that particular one. Oh, I forgot about one port on here. There's the Commodore serial port. For the Commodore drive, you got to be able to put stuff into it. I suppose if someone wrote a new core for it to be an Atari, you can make it down here and use the same pins.
Yeah, I was just wondering, the people you talk to, if people are interested in the Ethernet port?
Originally, I was talking about Ethernet, and I was going to use this Cirrus Logic chip that I was going to solder down, and then I started looking at the cost of it with all the transformers and connectors and stuff on it. It was going to be so expensive that it was going to drive the cost of the board up. So that's how PCI ended up on here.
Okay. So look at the RealTime Clock.
Yeah, but the physical layer stuff, transformers and stuff, it's very expensive. Those. See, the Cirrus Logic ones were kind of pretty inexpensive, like $3 or $4 for the ones that had a nice 8-bit interface. But all the supports are very expensive. Where you can go buy an Ethernet card, PCI for less than $10 for sure.
The filer
Oh, that's amazing. Well, when I started this, it was very expensive. That was what I found. So, anyway, we have PCI, so if someone wants to take a RealTech card that's very cheap, plug it in here and make it work, it's great.
At some point, I'd like you to talk about the software that people have talked about writing for it, what support there is for Commodore 64, the Commodore 64 environment, and also other operating systems or software that runs on top of it to take advantage of some of the nice features.
Okay, what you're saying was what software people have committed or maybe talked about to writing particular for the Commodore One. There's been a lot of talk, and I consider a lot of it probably just noise. Everyone says that, I'm going to buy one, I'm going to make this super duper operating system. But there is one person out there that has already proven himself. Joel Magnus or something, what's his name? Anyway, he wrote an operating system already.
Unix?
No, not the Little Unix. This is called JOS. I think the Little Unix project is pretty much dead right now. It's still done at all. Last time I was there, the updated page was like 1997.
It's still going on.
Excellent, great. I'm excited about that. The JOS, this guy said that I've been actually talking with him quite a bit. He's like, can you add this feature? Can you do this type of interrupt handling on here for me? And so we've been kind of gearing part of the C1 so that this new operating system that he's writing that works with the super CPU on the Commodore 64, which is a 65816 accelerator. He also wants to take advantage of the glitter and the copper and the more memory and the IDE. He's very excited about that. So he's committed. There's been some people out there that made some cross-development tools for me to help actually test video modes and stuff, which was very nice. And so there's a few cross-development stuff out there now. I haven't released the register map yet because it's constantly changing. As I make changes to the design, sometimes it's easier to group registers with other registers. It makes smaller design. Like I might have one video register just because it's placed on a certain part of the chip. I might group it with the sound register just because it's it decodes better for whatever reason. So yeah, there's a lot of noise out there about that. As far as other machines, I really haven't got much attention for other machines. I haven't really promoted it as that. It wasn't until this last revision that we decided to put a CPU slot on it so that Z80s and stuff can be hooked to it. But it's just me developing this, so it's really hard. I was working full time the last 3 months or so, and I'm having very little time to work on it. Now I'm at school, so now I have plenty of time. Yes.
When this becomes available, how open will the design be? Like in terms of all your HDL and all the stuff that's been developed?
No VHDL. I might, if someone's doing a design, I might give them some edicts or something that they can't directly, reverse engineer. I mean, I put a lot of effort into this, and I don't want people making clones of the C1 or taking the individual cores and making little add-ons for other things. And then, it's 2 years I've worked on this for nothing.
So to answer that, on that same question, you said that the VHDL binary will be present on the compact flash. Do you have any intellectual property concerns about somebody snatching that binary image?
Well, the actual VHDL, there's when you're doing HDL designing, you have this high-level language. You run it through a compiler, and it makes this thing called an edict, which is some kind of intermediate level. Then you put it into this thing called a place and route piece of software that actually takes that edict and can read that, which is, you can't really get, you can't infer anything except for the functionality of the edict, so you can't go make any changes really to that. So then you place and route it. When you place and route it for a particular chip, I can put this in a Xilinx or in a custom ASIC if I want it. Then you can, then it's in this encoded format that only goes in and programs a particular chip. So no one's going to, definitely at that level, and that's what's on the compact flash, is what talks to these two chips. That's, it's pretty impossible to do anything with that. So we're making more of this exact.
Well, but what about somebody sitting down and figuring out the signal lines that you have on that board and saying, oh, well, I can...
Well, that's going to be open. I mean, I want a schematic to be out there for people that want to make their own things that go into this board. I don't want to be like, oh, I'm the only one. I put some protection in the cpld, so it's going to be in there. I'm working on it. It's going to talk between the cpld and the FPGA, and I'm the only one that's going to program these cpld's. And if this doesn't send out the right stream, then it turns a refresh off on the memory. So it's going to be very hard to make an exact duplicate of this chip. So it's a pretty big linear shift back register, so it'd be very hard for someone to get the taps on it.
They'll copyright the algorithm in the cpld, so if somebody copies it, they would have to do a violation.
And I'm just going to make it annoying enough. If someone breaks it, they deserve to be able to copy it. They're going to put so much effort into it. It's kind of fun. But I do want people to make their own things for this. It'd be great. Configuration files.
Atari once had their custom chip transmit copyright Atari Morse code.
Oh, really?
So if they found a pirated machine, all they had to do was hold an AM radio up to it, and if they heard copyright Atari in Morse code, they could prove it was one of theirs.
Really? That's amazing. I love it. Yeah, it'll. I don't know if it'll actually come with the board, but there will be schematics available out there. So do with those what you want. Cause best condition, burn the board if you want. So it's not going to be, just the average user's not going to be able to configure this to be Atari on their own. It's very difficult to make a high-speed design. So.
Don't have enough replaceable fuses so people can use force drives on it, right?
I hope not. That'd be really good.
What's the warranty on the board?
Yeah.
It's on the box.
And for you, not. No, it's actually it's kind of a hacker's board. I'm pretty much going to be guaranteed to work when you get it. That's. I mean, we're not going through an FCC or anything on this. This is just purely experimental. So, we are making some effort on the enzyme heat, putting a lot of ferrites and stuff on it, so it's not going to make people's pacemakers stop. So. Yes.
A question on that one. There are some different
Well, I'm just considering Commodore One as like a code name, maybe. I'm not even sure that's going to be the exact name of it. Someone wants to put this in the car, so Commodore One. I don't know about that. Most likely, it'll ship with no ROMs, and then just a boot up disk. You put your own ROMs into it. That way, you have to be honest and say, "Oh, I own a Commodore 64 or whatever." Like just use it as an emulator. I figure that's how you get away with it. It should be easy enough for someone to put their ROMs into compact flash or IDE. So that's too much of an issue. Any questions?
What's it going to be?
Oh, shipping? Well, I don't know. For the last year, I'm like, oh, give me 3 more months, give me 3 more months. And it hasn't happened yet. But now that individual computers have stepped up the plates as well, they made an announcement that it's going to be December. So it's the actual board should be out in December. Whether how usable it is a different question. We're working real hard to make sure that electrically it works. We're not. I quit concentrating on making the guts of the chips work exactly right. So for those of you that go out and get the very first board, and turn it on, it'll say Commodore 64 or whatever bytes ready. Then you try to load a program. It may not work because I may not have implemented everything yet. But that's since it's reconfigurable, updates will be available. I haven't figured out if I make a Pong game for this or something, how that'll work exactly, how you download that or pay for it. If it'll have unlimited updates or not, I'm not sure. Because, eventually, if I sell 20 of these boards and then people are expecting to update it forever, it's not going to be worthwhile.
So you're just going to release like a new Kickstarter this for it?
Exactly. We were just talking about the Amiga the other night and how crazy it was they shipped it out with the bad software. It's kind of it's going to have bad software at first. It's going to take a lot of feedback from people that buy the board to say, all right, this program doesn't work, and they're going to have to tell me why it doesn't work instead of like my GeoCalc doesn't work. They need to tell me exactly why it doesn't work. So it's going to be important getting it to the right people's hands immediately.
You're going to ship it with Commodore Basic?
Well, I was just saying earlier about shipping it with ROMs. I don't think I'm shipping with any ROMs until I don't know what happens because Tulip over in Europe, I think, still has the right to Commodore trademarks. Maybe the ROMs, the gateway, or somebody has it. So probably with just like, oh, by the way, if you go to this website, or there might be discs floating around. There's people that are talking about converting Basic 7 and Basic 10 from the Commodore 65 to work on this. Which should be fun. That was a really good Basic. There's the programmer of Robert. Do you know who the program, what the name of Matthew's program is? His assembler, NAS. Is it called NAS?
I believe so. Yes. The last 128.
Yeah, NAS 128 to Tyler. He's said he wants to convert it over to work with 65816, so hopefully that'll be available for it right away. That was a pretty good assembler, I guess. What else?
So is this product similar to is it similar from the inside, from a programmer point of view, as the super CPU that's available for the 64?
Yeah, it's a lot like it. The super CPU was just basically the 65816 wrapped onto the C64. There wasn't much functionality added to it. There were some mirroring functions which handled the interface between it and the C64's memory. This particular memory interface I have on this one is totally decoupled from the video. So in theory, it should outperform the super CPU in some aspects when it's all up and running right. Because when you can write to bit registers and SID registers, you just go full blast at them. There's no limitations on that. So that'll be nice that you won't be interrupted in processing. And there's Gideon Schweitzer somewhere in Europe that's working on a RISC version of the 6502. exciting to probably fit into the CPU slot. Or he's talking about maybe even PCI, so you can have 32-bit access to the RAM.
You need a separate register to count real clock cycles because anytime you do pipeline, you all of a sudden become very obvious.
Yeah, with pipelining, programmers are going to have to quit doing the counting cycles and stuff. So hopefully the processor will be fast enough that they can do everything they want without counting cycles.
Right, but I mean, a person could add like a separate little register out there that synchronizes things. In other words, a counter.
Over mouse and installs it. I've been working on, as far as the emulation, since everything's decoupled from the processor, I made a little simple state machine that kind of emulates the bit. Just halts the processor just willy-nilly when you turn on so many sprites, you know that it halts the processor for so much time. And I played with that, and that seemed to help with these demos that have little raster bars and stuff every time real close. And, when I played with that state machine, I could get the raster bars to show up in the right spot. So I'm sure somebody can do that.
Along the lines of what you were just mentioning, I would also second either 32 or 64 cycle counter that just simply monotonically, just increments every clock cycle at some level, very low, so that programmers can get access to it to just keep track of time. It's an important aspect in operating systems.
Well, and the C64 itself had all the programmable timers.
Above and beyond timers, I work with chips that do supply timers, and we have to use one of the timers as a cycle counter, and it interferes in ways that are structural, absolutely. If you have room for a 32-bit cycle counter, that would make a big difference.
Well, with I guess I'll have to research. I'm not quite sure what to say about that. So that might be something that have to be added to the CPU core if it's actually counting. It
just needs to be a counter on the motherboard that the CPU can get access to. That just increments so that the operating system has unique timestamps. That's all I ask.
Yeah. Yeah, maybe I'll talk to you about that afterwards. I don't see where it differs so much from
Does it need to be linear or merely monotonic?
Ideally, it would be linear. Yeah, I mean, that's a good point. I appreciate you saying
you have a
that.
question?
Yes, you apparently started out to build a Commodore VGA Monitor Adapter. There's still a large installed base of worldwide of Commodore computers. Is there still a chance that you might get back to that project?
Maybe. Yeah, maybe. I'm not so sure. I think there is a lot of people have asked me for that.
Right, I think there's a big need for it because of the lack of the modern RGB computers, or monitors, I mean, and they're thrown away in dumps, all VGA, super VGA. Monitors that we could be using.
I might do it someday. It'd just be like a little side project. 2 minutes, all right. Any quick questions here before moving on? No?
And again, you picked up all this knowledge just haphazardly. You don't have an electrical engineering degree.
No. I got a hold of good people like Joel here. Joel does this for a living. He's like, hey Joel, I'm having this trouble with making this big thing work. What do I do? I'm sure I annoyed him a lot, but I've got a lot of help during this project to learn. So that was the whole thing, starting from ground zero almost, and now I'm pretty good at designing stuff for cpld's. I'm going to school for electrical engineering. They're letting me skip to the 4th year of the program, so it's nice. And still kicking their butt. I made this last week. I made Pong in a 64 macrocell cpld just because the teacher scoffed at me. I went home 4 hours later. And, show you scoffing at me. Any other quick questions here?